How's it going? Ethan here. I went to the Southeastern Laser Enthusiast meetup and picked up an interesting device set off of Steve Roberts, which it extracts digital laser show data from videotapes that have been encoded by a similar setup. And I'm in the process of kind of reverse engineering how it works. And I figured I'd do a short video to kind of show my progress, where I'm at, and how the device works, as a few people have been interested in it. So here we go. So sorry the video is shaky a bit, but I'm going handheld. The particular units are made by a company called Engineering Corporation, which I believe was originally out of Boston and now resides in Baltimore. These devices take a video input signal on the rear from VCRs, during that time it was VCRs. And what it does is it extracts the digital data to feed digital analog converters for a number of channels for laser show projection. The particular units actually extract two channels for two different scanners from a single videotape. And I was told they're at 14K PPS, or 14,000 points per second. You can see here on the front, there's a X positive and negative, but only a single Y output. There's a feed for shutter and three color channels, red, blue, and green. The A, 1, 2, and 3, as well as the shutter, seem to be a digital output, while the red, blue, and green seem to be 6-bit Dax. X and Y appear to be 12-bit. Simple analog controls: Y position, Y gain; X position, X gain. Manipulate the signal feeds into op amps and whatnot. And everything's duplicated for the second channel down the bottom. Now I've only got one laser projector, so I've only got it set up once, and most of the tapes that I've seen so far only have a single channel encoded on them. So LEDs that show the lock-in, I've never seen them really kind of come or go. They're not analog or anything where it shows the level. Channel A or B, it detects whether or not it's active or if there's a signal there. And detection is kind of adjustment, per se, to tune in the signal feed. The setup that I have right here, there's a VCR that's actually been modified, I was told, for recording, although I'll talk about that in a minute. This is a SVHS VCR, though most of the tapes seem to be standard VHS in quality. This VCR is fed through the composite video output into the rear of the decoder. On the front, this here is hooked to an ILDA standard connector, which goes up to my laser projector in the wood box here, which is on at the moment. And I've also got the pass-through for the video connected to a television monitor, so we can see what the actual output looks like. So far, my adventures, I've been working pretty hard to kind of map out the schematics, if you will. I started taking notes on paper at first, and it just got kind of overwhelming. My actual intention is to use a TNC3 style microcontroller board, pull the data directly from the digital bus before or as it's being written to the DAX, and then echo that out of a USB port and capture it on a PC. So it's my goal to convert the library of videos over to direct data dumps. I'm aware that I could go from the analog ports on the front into a sound card, ADAT machine, or other analog capture device. However, then it's kind of going from digital domain to analog back to digital, and I think it would be best to try to capture it straight digital from the machine before there's ever that further analog conversion. That being said, it's been a little bit tricky. It's fairly complex and it's kind of strange. There is no processor in the unit. There is some memory, and there's an EEPROM. The EEPROM probably stores a list of values that cycle through for some sort of operation. I haven't quite gotten there yet, but first off, I guess I'll run a demo on the unit so you can kind of see what it does. So there's a videotape in here now. This was from a New Year's Eve show. And so with it on play, you can see the unit is locked in, the video level, noise gate, whatever, and channel A is active. Let's see. So the actual laser output, as you can see, can be seen right here. This here is kind of a New Year's Eve countdown, and there are some glitches. The tapes are quite old, and these are the newest of the bunch, so we'll see how the conversion goes. I actually see there's a little bit more noise than normal, which can probably be adjusted. And now it's a bit better. If I take the adjustment too far off, you'll see it kind of just falls apart. And it's kind of cool itself, but so that's that. Now when it comes to the actual video signal, let me see if I can't get this brighter. This TV's kind of. So this is the direct digital data as it can be seen on the video signal. I experimented with the encoder unit a bit, and I determined that this side here actually contains Galvo. I believe it's X or Y, and this here is X or Y. So these are the 12-bit DAX. The first chunk here is both 2 color channels, which I believe were like red and green, and then here I believe this section here was kind of blue, as well as the digital inputs. Rough guess, I'm not sure if the actual color stripes are related to like a clock shift, and then the data shifted off of that by the the change in it. It's been suggested, yes, the software decoder could be made and try to extract this out of a capture for video. When it's in 2-channel mode, the actual video kind of looks quite a bit different, almost like it's maybe the second channel is written on the odd frame or something, so even is one channel, odd is the second, so it kind of gets kind of bad. I do not have my Firewire bridge here in Norfolk, and Nova, I think it's down in Norfolk, so as soon as I get a hold of the Firewire bridge, I'm going to actually try capturing one of these videos straight to a computer through Firewire, and then see if I can play it back and see if the video actually plays properly. I think all the equipment I have here is all SDI and digital HD stuff, so that's kind of this. I will actually throw in another tape. You can kind of see a little bit more effects, and then I'll tear the unit open a little bit and point out some guts of this thing. So the tape collection I have is about 6 VHS, 40 plus beta, and a number of U-matic tapes, which are 3/4 inch commercial format. And I have a beta VCR, it's just down in Norfolk, as well as access to, let's see, this particular tape has audio. Oh yeah, so this one here says I think it's a Firestone video. So not sure what's up with the hotspots and whatnot, but so I'm going to rewind the actual video and off it goes. So that's just the tail end of it. Up until that point, it's pretty much nothing in there except for audio. Some of the video files seem to be missing, say, the analog color, but contain XY patterns. Kind of like it's meant to be used with an analog signal generator or something for the color modulation, and then others seem to have the color modulation but lack the XY. So they're probably meant to be used with like an analog controller. I'm going to unplug this unit so when I tear it open, there's internally, I can't explain how far I've gotten. Top here there's a board that's kind of an analog adjustment board. It contains a bunch of op amps. I'm pretty sure the controls from the front feed into it for the adjustments. And in the middle here, these ICs are single pole, double throw switch ICs, which I believe the select switches here on the front are tied to for jumping the outputs between channel A and B. And I'm gonna, actually bear with me a minute, I'm gonna set this down. and undo this. Alright, so what I've now done is I've now lifted the analog control board and carefully going to fold it over. So internally what we've got, or what I figured out so far, more analog chips right here. This isn't going to work so well. Let me, kind of backwards from the way I've normally been working on it. Okay, so we have our analog chips right here. Down here there is actually 6 8-bit Dax. So there's 6 8-bit Dax right here, analog devices. However, 2 of the pins are tied to ground, so that kind of gives me the impression that they're only using 6 bits of each one. We have 4 12-bit Dax right here. There's 4 actual memory ICs, but these have a 4-bit wide bus. So it looks like the way they're kind of paired up into the rest. I haven't totally figured out yet how the memory buses are arranged as far as filling the 12-bit Dax, where the kind of offhang is there. There's these 2 chips that look like EEPROMs. The one is actually not an EEPROM at all. It's kind of a memory controller that's a FIFO buffer and 12-bit address driver chip. It's kind of the older off-the-market IC, which I've kind of figured out what it does. It's definitely pushing the address bus, but more to come on that. And there is an actual EEPROM here, which is interesting because there's no CPU. So most likely what's happening is that somehow they're driving the address pins on that and using the data coming off of it is probably just a pattern generator or something. Analog circuitry is over here that comes in from the video input, and so picking the data off of it isn't quite as trivial as I expected. I kind of just figured, oh, there'll be a CPU in there and an 8-bit data bus with some chip select lines. But so far that isn't the case, and I'm still working to put it all into a CAD file. So I've made some pretty good progress, but there's still a good amount to go, and a lot of things still are not explained. Mainly a big piece is what's driving the write enable on the DAX for them to pick up their data, and how is it getting converted from a serial data stream from the video signal into this. There's nothing like a 595 shift registers or any normal chips like that I've seen so far. The company is around. I talked to them. They do not have the schematics anymore, as the engineer that made them most likely left with them. So I'm in contact with them, and so it's kind of exciting stuff. It's a neat project. I'm looking forward to converting it, and I think what I'll probably do is take a lot of the shows and make them available, both the full video dump of the tape, the data dump of the off of the pick off of the DAX, and from there I should hopefully be able to generate a WAV file. Luckily the videos seems to be at a solid steady refresh rate, which kind of helps when it comes to converting that to WAV. Timing was kind of a big concern. If I start pulling the data from the DAX into a USB bus, would I have a solid time reference to use? And I think that's the case with the way it's being updated. So more information later as I make more progress. Have a good one.